Hello again, this is the Great Fez back again with Kerpollo 2 mission. Uh, this is going to be episode 2. We're going to be going over the docking script and how it functions. Um, for those that are not familiar with the Saturn V, after you're put into a trans-lunar or a trans-lunar or minmus in this case, after you get put into the transfer orbit, you detach from the third stage. The service module uh, turns around and docks with the Lunar Lander, and then the Lunar Lander and the service module both detach from the third stage, and then the two combined go on to actually get captured onto the moon, or in case Minmus, and the mission goes on from there. One shout out that I actually wanted to give to Toki Datic, hopefully I'm saying that right, on the subreddit. He actually gave me a thumbnail to use for these missions. So thanks a lot. I'm not very good at Photoshop or anything, so that was a really nice touch, and I really appreciate it. Also, on the first episode, I've put the code here on my repository. It's on the Ascent Evolution project, but it's on the Kerpollo 2 branch. So you can look at all the code, and the code that will be on here will be on another commit once I finalize all the code and commit it for this video. All right, so back to what we're doing. The two things that I want to talk about just programming wise is the way that this is set up is there is a if statement right here, which sets the docking stage to +1 every time I turn the lights on. So that's how I'm going to be controlling this. So I can talk about it and just set it manually. I commented all the code that actually sets the docking stages automatically. So this will be a step by step. But usually, if I could just let it run and it'll just dock on its own, I don't have to manually do anything. The second part, this is something I learned and I got help from Blogeron. Gosh, I'm so bad at names. Sorry, but he's also on the Discord. So thanks a lot for this. He showed me that whenever you actually dock, if your target is the docking entity that you're trying to dock to, once you dock, you become like one ship, and your target becomes null. So if you try to call the target, it breaks. So the docking port, if you guys have noticed in KSP, they eventually go into this acquire state. It's called acquire docking or something like that, but I'm just looking for the first word, acquire. But once that happens, they actually magnetize and then they connect together. So once that happens, I actually, set capture to true, which goes into some of this other logic. It doesn't go into any of these if statements if capture is true. Oh, sorry. And then it unlocks the steering. It turns SAS on. It sets the control to neutralize, and then the target, it just desets the target and wait 0. So once all that happens, then it goes through this code just so that the two ships can just dock together. I don't once they docked it, it won't break the code and it can continue on because I want this to be all as seamless as possible. So that this really helped out. The other thing I was going to show, or I'll show these when they actually occur, but vectors and vectors, they're very, very powerful tool. I use them all the time in all my other scripts. So if anybody doesn't know how to use them, using vectors is a fantastic way to do it. This is an awesome feature that the KOS devs added, and I've been loving it ever since. I don't use it too often, but once I start getting confused or need to do some debugging, this helps out a ton. For now, I'm using it as a tutorial effort, so I can show you guys all the vectors that are happening. And I'll go ahead and do the first part here. So all I'm doing is just going to reboot the ship, and I'll go into the first part of the script. So right now we're in docking stage 0, where nothing's happened. We're just pointing ahead. Nothing's turned on. So here are all the vectors that I've created. Sorry, pieces are just floating there. The first three to talk about is the 4 vector, star vector, and up vector. those are the facing, are essentially the axes of the docking port. So up vector, that means like if you're sitting on the ship, then up your where your head goes through the roof would be this vector. To your right would be the star vector, and forward is this direction. Um, and I did this so that I could show you guys how the ship is actually moving and aligning, and it's really nice to see like a relative orientation. The next one is the target relative position. This is literally just a vector from this docking port to this docking port. This off-axis maneuver, I'll talk about that when that comes up, but that's how we're going to be aligning this 4 vector with the facing 4 vector of the target. And then right here, they're kind of hard to see because they're overlapping, but there's a target relative velocity and the desired velocity. So I'm going to pause this for now. Actually, I'm going to reset it because they tend to drift away and then it becomes a big mess trying to go through the parts. So, um, so let's go through the functions so that we can understand what's happening here in the later stuff. First two are pretty self-explanatory. It just pulls the target relative position. Um, I use this checker function because whenever you're doing all these kinds of docking stuff, you don't want to use the ship's position because the ship's position is actually like in the center of gravity, I believe. But we actually need to look at the position from the docking port. So I have this checker in here so that I can actually manually input the docking port part, and then everything is relative to the docking port. So this one, it just checks the target position, subtracts it, and it'll return the vector there, and it points towards the target. Um, and it has both of these have this if has target because again, if you're docked together and there's still code that's trying to call the target, it's going to break because there's no target, so everything just it just breaks. So I check first if it has a target, then I do this. If not, then it just returns here because I don't call the target. So that's just a little fix in case anything goes wrong. I never had to actually deal with this. I just did it just in case. And this one here, there's two parts to this because if it's a part, you can't actually ping the velocity of that part. Or I should say, for all the cases I've seen, you have to actually call the ship first. So if this was a part, it could be on another ship, but you still need to call the vessel, in this case ship, and then velocity, and then orbit to get the velocity there. And you just subtract the two to get the relative velocities, and then that outputs and good to go. This vector to translation is quite awesome. Let me go through the documentation here because I want to show this as well. This is not something that a lot of newer people tend to look at because this is raw control. And raw control essentially means, think about in a car. A car, if you were to press on the gas, you're controlling how much gas is going into the car. You're not controlling the speed that the car is going to. You're just controlling the power. That's what these controls are essentially doing. This control 4 controls how much the ship is being propelled forward by RCS. So if I set this to 100%, that's like me slamming the gas. If I let go to 0, then or if I set it to 0, that's me letting go of the gas. And if I put it at -1, then it's me applying the brakes. Now, the 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 part of that I can compare this to is the cooked control stuff that, like, for example, when you say lock steering to and then a direction, that actually goes through KOS itself and does a bunch of logic to. Oh, what did I do? Sorry, it goes through a bunch of logic to actually it calculates all these for you. That's exactly like cruise control, right? When you turn on cruise control, you say how fast you want to go, and then the car controls the gas. You don't control the gas; you just control how fast you want to go. So that's that. Anyway, to move on to to move on to the translation. Now, this 4 vector is again just the direction forward of the ship, and then up and then starboard, right? So if I wanted to point my to turn my ship, you know, up and to the left, I have to give some control to the forward, some control to the starboard. Now, this translation actually does those calculations for me. If I give it a vector, if I give it a vector, it actually converts that vector into starboard, top, and fore components. So that's what this is for, because for example, if I say I want to accelerate along this vector, or I want to accelerate with this much acceleration in along a certain vector, I need to convert that into the ship's raw inputs, and this translation is how I do it. So I give an input vector, I do the v dot of the top vector, star vector, and fore vector, create a vector output in that in this order that was shown here. Starboard top 4, starboard top 4, and then I set the translation control to the output vector. Pretty easy. The next one I want to talk about is this position vector. What am I saying? Position correction. So this is essentially kind of like if I told you to run as fast as you can to some point and then you know, um, stop exactly when you get to that point. So if you guys catch that, that's kind of like a suicide burn, right? In this case, instead of just waiting to just throttling down the whole time, you're actually accelerating and throttling down. So suppose that the ship is, still or relative to the target, it's not moving, and I say I want you to move, 10 meters to the left. I input the target position that I want the ship to go at. This checker again is to set to the part instead of the ship, because the ship and the part are two different positions. So the target position that I want to be at, and then this max acceleration is hard coded because I didn't feel like doing all that stuff, and 0.5 thrust is pretty good. Anyway, then once I get the target position, I get the distance. I calculate the desired speed using this equation, which is the equation that derives the maximum speed you can be at to given a constant acceleration to stop yourself exactly when you reach a certain distance, right? So if you're going 100 meters per second and you have to go a kilometer, and you have this much acceleration, or I'm sorry, if you're 100 meters away with this much acceleration, how fast, what's your top speed that you can go before you need to go full throttle? This gives us that, and then our desired velocity just converts it into the velocity that we converts it into vector form, right? So we know the speed, the direction is we want to go directly to the target position, and then you multiply the magnitude, which would be the desired speed, times the unit vector, and you get the desired velocity. Now you subtract your desired velocity from target relative velocity, and you get the acceleration you need to do. So if you divide that by your maximum acceleration, you get an output, which would be a throttle output. So if this turns out to be more than 1, then you just need to go full throttle until you reach the desired speed. But that's how this works, and this is how I'll be simplifying the process of docking, which it's going to be, it's fun to watch for me, so I hope you guys enjoy it. But you'll see how simple it is once you break it down into these 3 phases essentially. And this axis align maneuver is just to align the 2 vectors so they're facing exactly onto each other. All it's doing is just finding the you can also use vector exclude here, but I'm just subtracting the target or vector from the relative position, and so it just gives me the vector that's pointing towards like the axis from my ship, and you'll see that whenever we start running. So again, just to reiterate, we have the lights. So every time I turn the lights on, we're going to go through one of these portions. First thing, after we detach, we're going to flip the ship over. So this is just going to be doing, lock steering to facing vector direction, and then until the two are within 1 degree from each other, we're going to remain in this loop, and that's just to make sure that we're aligned properly. Then I can press the light on and switch to docking stage 2. This is going to kill all the relative velocity. It's just gonna make sure that I'm zeroing out the velocity. And this 10 here, it doesn't really matter because since it's a relative velocity, all you have to do is just point retrograde to that velocity and it will just slow you down. And this is just to make sure it does it a little faster because I don't need it to be controlled in any way. The next part is we're just aligning the two docking ports. And lastly, we're just going to make the target position the relative target, the position that we want to go to, okay, the position correction input, the target relative position. So we're just going to say, I want my docking port to be at the same spot as my target docking port. And it's just going to, again, do kind of like a suicide burn maneuver, but accelerate me and then decelerate me until I'm close enough to the target that the magnetization happens, and then we're just going to dock and go. So, without further ado, let's increase the font here, make it easier for everybody to see. Start. So again, we just detached. No functions being run right now. We're at docking stage 0. And if I turn the light on, we're going to go into 1. Now we're going to align, and you can see how it makes it very nice and easy to visualize where the ship is pointing and everything once we have these right here. This is one of the reasons why I needed this next part, is because that maneuver just kind of pushes me away because of the way the RCS is pushing. It's not equal, so it makes me move in one direction. But we want to reduce our speed to 0 because it just makes things easier, right? If we start from 0, we're not going too fast. We don't have to change our throttles or anything, and it makes everything a little bit easier to start from something fresh and clean and as close to 0 as possible. So right now we're at 0, and this is that off-axis maneuver that I was talking about. You can see that the target relative position is here. So if there's another vector that was pointing this right here, if you subtract this from this target relative position, you get this off-axis maneuver. And it's not perpendicular or anything. It's actually aligned along there. So this next part, we'll actually get to see the target relative velocity and the desired velocity in action. If I turn it back on, now you see the desired velocity is pointed directly along the off-axis maneuver. And this target relative velocity is essentially the speed that we're moving at. So the RCS is working pretty hard to get these two aligned, and once they do, it's a little bit off, but it starts to slow down. And eventually, again, this is essentially like a suicide burn, right? We're accelerating as hard as we can, and now we're decelerating pretty much as hard as we can until we zero out that position error, or essentially move the ship to where I want it to be. Then once the target relative position is 0, you can see that the 4 vector, so my docking port is aligned pretty perfectly with this docking port. And then lastly, again, I want the position of the docking port to be right with this docking port, right? So we're just going to set the desired position, or the position correction, to here, and then just magic happen. Desired velocity is here. We're just pulling full forward with probably a little bit of correction here and there, and then we're gonna start reducing that velocity. And then they'll start magnetizing, turn everything off, and boom, docked. That's that. Um, Hopefully that all makes sense to you guys. Again, I'm gonna make this available for everybody. Um, the it's really daunting. Docking is probably one of the hardest concepts to do because it's not as pretty as an orbit where you're moving. It's literally free space. You have to control all the outputs. But if you make it really simple, like if you align the two together and then you don't move their orientation, it makes the translation. You can almost treat them as point masses, and then everything becomes much easier. I highly suggest that. I highly suggest not making sure that the two axes are oriented properly, um, and or aligned so that they would be touching if they're right next to each other. But um, make sure that you don't move those orientations because once you start doing that, then all the vector math becomes a little weird. Not that it's wrong. I'm trying to make sure that it's as easy as possible for everybody. And then the maneuvers are pretty simple. But just to clarify, this is assuming that I'm in front of. So I'm if there's a big plane right here. Think of it like a big like a vertical plane. If my ship is in front of it, then this will work. If I'm behind it, I don't have any logic to move in front of this plane and then dock. So just be careful whenever if you're using this to make sure that your ship is in front of what you're trying to dock with. And lastly, this ship doesn't really the Lunar Lander and third stage don't really move. So you might also want to add some logic to turn the SAS on for this so that it actually doesn't move, or if you want, even change the orientation so that you don't have to do any sort of crazy flipping. You can do that too. It's pretty easy. I didn't need to do that, so I just didn't want to do it. And the reason for that is because this is not like some script that's going to be used for any purpose. Is specifically for Kerpollo 2. But I think this docking is pretty well suited and very simple, and I think a lot of people can benefit from learning how it works. Indeed. With that, I don't think I missed anything, so hopefully you guys enjoyed it. Try to I'm going to try to cut these videos down or at least keep them around 20 minutes. I went a little bit over here, but hopefully the next time that we meet, we're going to be talking about how we're going to capture because right now we're going to hit the planet if we don't do something. We're going to capture, deorbit, and circularize, and then we're going to uh, probably talk about the landing, although I've already had videos on how that works, so we'll see. Thanks a lot. See you guys next time.